Hello. Hello.
Yes, sir.
Yes, good morning, students.
Good morning.
Uh, okay, yesterday we have discussed about electromagnetic wave, basics of electromagnetic waves. And today we will talk about property of electromagnetic wave. So far we have discussed that electromagnetic wave consists of electric field and magnetic field, which vary periodically, and direction of both the fields are mutually perpendicular to each other, as well as perpendicular to the direction of propagation of the wave. Now, and also we have discussed that speed of electromagnetic wave can be expressed as the ratio of amplitude of electric field to that of magnetic field. And in case of light, we have discussed that electric field becomes dominant. Therefore, electric field itself is called light vector. Electromagnetic wave do not require any material medium to travel. And it is because of this reason, a wave or energy transported from sun to our earth in the form of electromagnetic wave. And basic source of electromagnetic wave that has been experimentally proved that an oscillating particles, charged particles, produce electromagnetic wave. Oscillating or accelerating charged particle produce electromagnetic wave. And today we will discuss about the Hertz experiment, who was the first scientist to discover that light itself is electromagnetic wave. And Hertz experiment consists of two metallic plates, one with copper and other with zinc. The copper or zinc plates are kept parallel and separated by 60 cm. And these two plates is just acting like a parallel plate capacitor. The metal sphere are slided over the metal rods to have a gap of 2 to 3 cm. You see here, metal rod. These two are the metal rods. And separated by a distance of 2 to 3 cm in between the plate. And induction coil supplies high voltage of several thousand volts. This is the induction coil, and P stands for primary, S stands for secondary. This is the block diagram, but in actual, this is a coil. One terminal of coil is this one, another terminal of this coil is this one, and these together is called primary coil, just like you have seen in transformer. And this is secondary coil. So one terminal of the secondary coil is connected with the rod S1, and one terminal of the secondary coil is connected with the rod S2. Okay, and this primary coil supplies high voltage, almost of several thousand volts. As a result, the plates and the rods with a sphere, here is the sphere, plates and the rods with a sphere constitute an LC combination. So far we have discussed LC oscillation in the previous chapter. So every chapter has a correlation with the previous one. So you must use the concept of LC oscillation in the previous chapter that you have gone through. So this is the essential parts of the Hertz experiment. Once again, remember it consists of two metallic plates, copper and zinc plates kept parallel and separated by 60 centimeter, and metal spheres. Metal spheres are slided over the metal rod to have a gap of 2 to 3 cm. This is the metal ball. This can be slide over this rod. This rod is connected with the metal plate, and this is the ball, and it is slided such that the separation between the two balls remains 2 to 3 cm. And this is the induction coil. There are two induction coil, primary one and secondary one. In primary coil, high voltage supply is fed into the terminal of the primary coils, and a corresponding induced voltage appears across the secondary coil, and which is connected in actual contact with the rod and balls. So plates and the rods along with the spheres constitute LC combination. It means you can say that these plates act as a capacitor and this system act as a inductor, and that's why it is called LC combination. So an open ring, metallic ring of diameter 0.70 meter, or you can say 70 centimeter, having a small metallic spheres act as a detector. An open ring, you see here, this is the open ring, not closed ring, and because it has 2 ends, it is called open ring. And this open ring has 2 ends, and 2 ends is attached with the spheres which act as detector. So this constitutes another LC combination. So this also act as a LC combination. So altogether you see here is LC combination and here is also LC combination. Here, just like this, ball 1 act as S1 and ball 2 act as S2. So whose frequency can be varied by varying its diameter. I mean, here if you want to vary the frequency, then you must change the diameter of the ball. And due to high voltage, the air in the gap, a small gap between the sphere, get ionized. Here you see, here is the air, and because of high voltage supplied by the induction coil, the air itself get ionized. It means it will have anions and cations, and hence these 2 ions will move to the opposite ball. And so due to the high voltage, air in the small gap between the sphere get ionized, and this provides the path for the discharge of the plates, a spark begins to pass between the spheres. As a result, because these two ions will move towards the spheres in accordance with their polarities. So a very high frequency oscillation of charges occurs in the plates, and this results in high frequency oscillation electric field in the vertical gaps S1 and S2. So you see here uh, electric field with high frequency will exist because of this ionization and oscillation of ions. So consequently, an oscillating magnetic field of same frequency will set up. I have already told you that whenever a charged particle oscillating between 2 points, the charged particle itself generates electromagnetic waves. So here, because of high voltage, air molecules get ionized, giving equal and opposite charge in between the two walls, in between the space or space between the two balls. As supply is AC here, so ions produced in between the two balls will oscillate between the two balls because polarity of the supply will change periodically. That's why oscillation will occur. And because of variation in electric field, corresponding magnetic field appears there. As we have already discussed that here, that time varying electric field produces a space varying magnetic field. And also time varying magnetic field produces a space varying electric field. Because in a region where there is no electric charges and no conduction current, then Faraday's law and Ampere's circuital law takes the symmetrical form, indicating that electric field, variation in electric field can be observed as magnetic field and variation in magnetic field can be observed as electric field. So here you see region between the two ball has no charge and no current. So here Faraday's law of electromagnetic induction and Ampere's circuital law take the symmetrical form or take the symmetry form. So here, as because of high voltage supply, the air molecules get ionized and provides the path for the discharge of the plates, and a spark begins to pass between the spheres. A very high frequency oscillations of charges occurs on the plates, and this results in high frequency oscillating electric field in the vertical gap. That means electric field will oscillate along the direction S1 and S2, that is along y-axis, you can say. Consequently, because of variation in electric field and oscillating magnetic field, a periodic variable magnetic field of the same frequency will set up in the horizontal plane and perpendicular to the gap between the sphere, or even you can say the electric field, perpendicular to the electric field between the sphere. So this oscillating electric and magnetic field constitutes electromagnetic wave. As we have already told you that a wave which consists of two fields, electric and magnetic field, mutually perpendicular to each other and also perpendicular to the direction of propagation of wave. So here, because of oscillating ions between the sphere, two fields mutually perpendicular to each other comes into play, and the electromagnetic wave produced are radiated from the spark gap. That means you see here, this is the spark gap, and because of variation of electric field, magnetic field generated, and both the field present in this gap, so electromagnetic wave radiated between the spark gap and travels with the speed in this direction. And here this ring acts as a detector. So this wave will be detected here. You see, the detector is held in a position such that the magnetic field produced by the oscillating current in the perpendicular to the plane of the coil. You see here, magnetic field will oscillate perpendicular to the plane of the coil. This is the coil. And so the detector is held in position such that magnetic field produced by the oscillating current is perpendicular to the plane of the coil. The resultant electric field induced by the oscillating magnetic field causes the ionization of air in the gap between the sphere. Again, here ionization is created here in this gap. Here, variation of magnetic field produced high electric field. As a result, air in between the gaps of this ball get ionized. And these ions again will oscillate with the same frequency, as the magnetic field or electric field is changing. So a conducting path becomes available for the induced current to flow across the gap, and this causes a spark to appear at the narrow gap between. So here you see, and it was observed that this spark was most intense when the sphere S1 and S2 and S1 and S2, that is, in order to distinguish this, you can say S prime, S1 prime and S2 prime here. In order to distinguish it, this is prime, S1 prime and S2 prime, and here S1 and S2. So it was observed that this spark was most intense when the sphere S1 and S2 and S1 prime and S2 prime were parallel to each other. This was a clear evidence for the polarization of the electromagnetic wave. So Hertz was able to produce electromagnetic wave of wavelengths nearly 6 meters. After 7 years of this experiment, Jagdish Chandra Bose succeeded in producing the EM wave of wavelengths ranging from 25 mm to 5 mm. And this wave is called radio wave of short wavelengths. And it was this wave that was produced by Jagdish Chandra Bose, then used for communication, and invention of radio was there at that time. Because of this production of electromagnetic wave of wavelength ranging 25 mm to 5 mm. Now, Depending on the speed with which the charge particle is being oscillated, we will have a various component of electromagnetic wave. And in this way, we can have a spectrum of electromagnetic wave varying with frequency and amplitude. So here you see, this is the spectrum of electromagnetic wave. EM wave and range of the wavelengths and range of the frequency here. And this is the source of the wave and use of the wave. As yesterday I have discussed that at least one or two questions asked from this section every year, they will ask you which component of electromagnetic wave is used for what purpose. So it is important that usage must be learned, and even their frequency range and wavelength range and name of the wave. Electromagnetic wave is a broad name of the radiation, but this name subdivided into several small parts in accordance with the frequency and wavelengths. So first one is the radio wave. A radio wave is a type of electromagnetic wave whose wavelength ranges from few kilometer to 30 centimeter or 0.3 meter. This means that a radio wave is a component of electromagnetic spectrum having longest wavelengths and shortest frequency. So here, as wavelengths increases, frequency will decrease. Here, radio wave has frequency few hertz to 10 to the power 9 hertz. It is a frequency range. And source of radio wave is oscillating electric circuit. Like you have seen LC circuits. And usage of radio wave is that it is helpful in broadcasting the message or signals or program through radio and TV or television, etc. Next comes microwave. Microwave will have wavelength range a little bit shorter than that of the radio wave. So microwave is another another component of electromagnetic spectrum which varies in wavelength from 0.3 meter to 10 to the power 3 meter. This wave has a little bit shorter wavelengths than that of the radio wave, and it will have higher frequency range. Its frequency ranges from 10 to the power 9 hertz to 3 into 10 to the power 11 hertz. And its basic source is also oscillating electronic circuit. Source is same for both radio wave and microwave. Now, application of microwave is used for radar, that is analysis of fine details of atomic and molecular structure, and microwave oven. Next one is infrared. This is the third component of radio wave, a third component of electromagnetic spectrum, and it will have a wavelength range higher than that of the visible light and but smaller than that of the microwave and radio waves. So wavelength range, that is infrared wave ranges in wavelengths from 10 to the power minus 13 meter to 7.8 into 10 to the power minus 7 meter. And its frequency will be higher than that of the microwaves, and frequency ranges 3 into 10 to the power 11 hertz to 4 into 10 to the power 14 hertz. Now, it's a source how infrared wave is produced. Its basic source is molecules and hot bodies. That means infrared wave carries heat energy along with it. And it is infrared radiation in the spectrum of the solar radiation which carries heat energy from sun to our earth. So this radiation or this component of electromagnetic spectrum is responsible for keeping our earth hot and warm. If this component was missing in the solar radiation, earth would have been a frozen planet and life could not survive here. So you must give the credit to this component of solar radiation which helps the life on this planet. Now, application of this infrared wave is industrial use. It is used in medicine and astronomy, night vision device. It is also used in night vision device and greenhouse and revealing a secret writing on the ancient walls. You can use this component of radiations. Next, light or visible spectrum, visible parts of the electromagnetic spectrum. Light is a part of electromagnetic spectrum. It is also an electromagnetic wave which produce a sensation of vision in our eyes or which help us to see the object around us. Although light itself is not visible, but it makes you the things around visible. Light wave ranges in wavelengths from 7.8 into 10 to the power minus 7 meter to 3.8 into 10 to the power 7 meter, or even in angstrom. If you want to express it, you must say that 7800 angstrom to 3800 angstrom. And its frequency will be 4 into 10 to the power 14 hertz to 8 into 10 to the power 14 hertz. And basic source of this light wave is atoms and molecules when electrons are excited. In case of Bohr's atomic model, you have studied that when electron makes a transition from higher energy level to lower energy level, a photon is generated and that photon appears as a light. So basic source of this one. Now, application of this wave is optics and optical instrument, vision and photography. All this activity is done with the help of light wave. Now, fifth component of electromagnetic wave is ultraviolet rays. Infrared will have lesser wavelengths, higher wavelengths that of the red component of light, and ultraviolet wave component will have a smaller wavelengths that of the violet. So ultraviolet, beyond the violet color in opposite sense than that of the red one, here we can say that ultraviolet components repeat there. It is a components of electromagnetic spectrum ranging in wavelengths from 3.8 into 10 to the power minus 7 meter to 6 into 10 to the power minus 10 meter. And its frequency ranges from 8 into 10 to the power 14 hertz to 3 into 10 to the power 17 hertz. So you know here it has higher frequency than all we have discussed right now. And higher frequency radiation will be harmful to life, and source of ultraviolet radiation is atoms and molecules in electrical discharge and sun. Source of ultraviolet radiation is atoms and molecule in a discharge tube and sun. Medical application is there. Application for ultraviolet is that it is used for medical purpose, as in ultrasound scanning, and it is also used in sterilization and killing the bacteria. Because of high frequency, it can kill bacteria and germs in food stuff, and detection of invisible writing and forged documents. Fraud documents can be detected with the help of ultraviolet radiation. And fingerprint, as a forensic lab uses the fingerprint detection using ultraviolet radiation. And after that, sixth component of electromagnetic radiation is X-rays radiation. X-rays radiation will have even lower wavelength range than that of the ultraviolet and higher frequency range. So it is a sixth components of electromagnetic spectrum, which ranges in wavelengths from 10 to the power minus 9 meter to 6 into 10 to the power minus 12 meter. And its frequency ranges 3 into 10 to the power 17 hertz to 5 into 10 to the power 19 hertz. And inner or more tightly bond electrons in atom is the basic source of X-rays. Remember, inner or more tightly bonded electrons in atom are responsible for X-rays production or production. That means if you excite an electron which is innermost, that is tightly bonded electrons, then this electron, when excited and then come back to the original states, during that it radiates a kind of electromagnetic radiation which is X-rays radiation. Now application of X-ray is well known to all of you. X-ray photography, it is used in scanning the bones and fractures. And treatment of cancer also it is used. Skin disease and tumor, it is useful in that one. Doctors and experts uses this. And locating crack and flaws in finished metallic object. If there is a fine cracks present there in metallic object, then with the help of X-rays one can detect. Detection of smuggled goods in bags of persons. As you know, a smuggler used. So at airport or railway station, with the help of this X-ray radiation, one can detect. Then a study of crystal structure. X-ray is used in a study of crystal structure. And last component of electromagnetic spectrum is gamma radiation. So gamma radiation or gamma rays overlaps the upper limit of the X-rays and ranges in wavelengths from 10 to the power minus 10 meter to 10 to the power minus 14 meter. And its frequency ranges 3 into 10 to the power 18 hertz, which is highest frequency. Here you see 3 into 10 to the power 18 hertz to 3 into 10 to the power 22 hertz. It is highest frequency. So a component of electromagnetic spectrum having highest frequency is gamma radiation. And then what is source of gamma radiation? So radioactive substance is the basic source of gamma radiation. And application of gamma radiation is information about a structure of nuclei. Inner structure of material can be analyzed with the help of gamma radiation. And astronomical research, it is also used. One can use gamma radiation to detect the basic cause of formation of planets and stars. So we have discussed about a spectrum of visible lights and experiment, Hertz experiment. So for today, this is all about, and next day, we will discuss the next part of this chapter. Next descriptive part, we will discuss about that one. And I think that I will share today digital notes of this chapter, a complete digital notes, and then I will discuss about that. Thank you for today.
रिजल्ट कब मिलेगा?
हाँ जी, आज उसका टेस्ट का जो आपका 1 मिनट